Hi everyone, my name is Alexandra Papoutsaki and I'm an assistant professor of computer science at Pomona College. I'm very excited to be part of this workshop and join so many people who are interested in eye tracking. Today, I would like to talk to you about my work on using eye tracking to support remote collaboration. Remote collaboration is an essential part of the modern workplace. Following the outbreak of the COVID-19 global pandemic, remote work became overnight a crucial measure of public safety. In October 2020, a survey of more than 10,000 US adults found that 71% of those workers were doing their job from home all or most of the time compared to 20% before the pandemic. And more than half of the participants said that given a choice, they would want to keep working from home even after the pandemic. Even before the pandemic, a global survey showed that 50% of employees worked outside their main office at least 2.5 days per week. This dramatic shift in the modern workplace has been supported by collaborative applications on platforms like Google Drive, Dropbox, and Microsoft OneDrive, which are paired with synchronous media such as instant messaging on Slack and voice and video conferencing on Zoom and communication platforms like Microsoft Teams. Nevertheless, remote collaborators still face unique and long-standing challenges compared to co-located work groups. For example, establishing common ground, that is the presumed background information shared by collaborators, becomes more difficult, along with the lack of implicit cues and of task awareness, which can severely impact the quality and outcome of the collaboration. In previous works on remote collaboration, scholars have used dual eye tracking technology to better understand gaze patterns, for example in collaborative gaming. Each collaborator has an eye tracker in front of them, and afterwards, researchers can analyze their gaze patterns and see how convergent or divergent they were during different phases of the collaboration. Gaze sharing takes this one step further and moves eye tracking from a passive technology to an active one. Let me explain what gaze sharing is by using these two images of two remote collaborators whose gaze we assume that we can track. The user on the left picture is looking at the upper right quadrant, and their collaborator on the right can see their gaze location as that green dot. Similarly, the user in the right is looking at the lower left corner, and this is reflected on the screen of the collaborator in the left as an orange dot. As the user moves their eyes, their collaborator can see a visualization of their point of gaze on their individual screen in real time. My research lab has been interested in how gaze sharing affects and hopefully can improve remote collaborations. Among the many ways of sharing information between collaborators, we chose to focus on gaze sharing since it has been proven to facilitate communication in tightly coupled collaborative tasks by providing an alternative, non-linguistic channel for checking one's own and the collaborator's understanding of what was said. For example, in contexts such as collaborative learning, gaze sharing led to higher learning gain, while in pair programming, gaze sharing has been shown to improve communication by enabling collaborators to make efficient use of verbal references. Today, I would like to talk to you about two of our projects on shared gaze, with the first one focusing on a popular remote collaborative activity, that of writing. In contrast to the early 2000s, when synchronous editing was not well received, a recent study focusing on undergraduate students showed that 95% of student teams use synchronous writing in their collaboratively written class assignments. Changes in academic and workplace settings make remote collaborative writing a good application to assess the effect of shared gaze. Our work hypothesized that remote co-authors will experience a higher level of collaboration, that is, they will work more closely in the presence of their co-author's gaze, and that remote co-authors will perceive their collaboration as being of higher quality in the presence of their co-author's gaze. To explore this hypothesis, we developed iWrite, an application that extends Firebud, an open-source collaborative editor which is similar to Google Docs and now includes a real-time visualization of shared gaze. For example, in this video, you can see that the gaze of the collaborator is highlighted in blue. When both co-authors gaze at the same part of the text, the visualization turns green. We kept in mind that collaborative writing evolves through several phases, and authors can have very different writing preferences. It is unclear whether authors would like to constantly see their co-author's gaze. Therefore, we introduce a feature that enables authors to deactivate gaze sharing by pressing this button or with a hotkey. We used iWrite to evaluate our two hypotheses and conducted a lab study. Our study design included 3 writing tasks of similar difficulty, where authors were asked to summarize a science news article. Each task could run up to 15 minutes. Participants were placed into one of two sequences, NGO or GON. In NGO, they started with a writing task where I write collapses into the baseline form of Firebird. No gaze sharing happens, that is N. The second task switches to constant gaze sharing, that is G, while in the third task, we allow users to deactivate the gaze sharing feature if they wish to, that is O. Similarly, in GON, we start with gaze sharing being constantly on, followed by optional gaze sharing and no gaze sharing at all. In total, we conducted a study with 20 pairs, 10 for each sequence. In our setup, we simulated the remote nature of collaboration using two separate workstations with individual viewports. Each participant had an eye tracker mounted on their display, and their gaze was transmitted and visualized on their co-author screens. The pair communicated via Skype audio call. As a first step, we measured the effect of shared gaze on the work coupling using a scale developed by Neil et al., which distinguishes between 6 levels of collaboration, ranging from cooperation as the highest all the way to no interactions. 2 independent raters coded the screen recordings of all 20 pairs according to this scale and assigned one of these 6 levels to each section of interaction. What you see in this figure is the percentage distribution of the 6 collaboration levels across all pairs during the no gaze N, gaze on G, and optional gaze O visualization conditions. As we can see in dark blue, the proportion for the highest level of work coupling in cooperation increased in the presence of gaze sharing. Similarly, the no interaction percentage in yellow dropped, which provides evidence that gaze sharing leads to higher levels of collaboration. The argument that gaze sharing leads to higher levels of collaboration was further supported when we separated our pairs into the 10 pairs where at least one participant chose to deactivate the gaze visualization in the optional condition, and the 10 pairs that both participants kept it on for the entire task. We noticed a significant difference in the work coupling. The highest level of work coupling, cooperation, which is shown in dark blue, is significantly lower for the pairs who deactivated gaze sharing. As an additional example, these two figures correspond to 2 pairs that performed the tasks in the NGO sequence. The top figure represents a pair who kept the gaze sharing feature on during the optional condition, and we can see that the cooperation was a dominant level across all tasks, as shown in dark blue. The bottom figure represents another pair who deactivated the gaze sharing feature during the O condition. We can see that in contrast to the G condition, they spent significantly less time at the cooperation level, that is, their work coupling was lower. We also provided questionnaires at the end of each task to see the perceived quality of collaboration. The following statements received significantly higher scores in the presence of gaze sharing. Participants reported that gaze sharing led to improved mutual understanding, joint attention, smooth flow of communication, and improved the exchange of arguments and overall awareness of their partner's activity. In addition, at the end of G and O conditions, we asked for feedback for the gaze sharing feature of iWrite. Participants further articulated the improvement in coordination, collaboration, and awareness. iWrite and gaze sharing was overall seen as an innovative tool that makes writing more engaging. Of course, there are always issues, and participants also reported that gaze sharing can be distracting as the visualization frequently moves. Eye trackers are known to lack accuracy, which can lead to technical difficulties. Finally, as writing can be a self-reflective process, participants noted that it increased their self-consciousness. At the end of the study, we conducted interviews in a conversational format. Half of the participants in the GON sequence missed the gaze visualization during the last writing task when they could not see their partner's gaze. This highlights the usefulness of gaze sharing on collaborative writing. Pairs under NGO could not experience the lack of gaze sharing during N. Because of the time it took for the participants to get used to the constant movement of the visualization on the screen, many participants said they only realized the usefulness of the gaze when they no longer had access to it. The reception of the gaze visualization varied largely even within a pair. For example, when one participant explained that they did not see its usefulness since they could communicate through voice, their partner responded, "I really liked it. It was cool, because when you were going to look for information, I could go and track where you were looking. I was a fan." The success and challenges that our participants reported showed the importance of accommodating for individual preferences and allowing the user to choose when and if they want gaze sharing. As one participant concluded, "I like the optional one, because then the person has a choice." So our first project supplemented existing literature in showing that gaze sharing leads to better collaboration performance as well as increased levels of mutual understanding and joint attention in diverse settings. However, gaze sharing has only been studied in settings with audio or gaze-only communication. We believe that this is an important omission as text-based media such as Slack are widely used in personal, educational, and professional circles. Chat is an important medium in remote group collaboration and in environments where voice or video communication is not suitable, such as in shared households, open offices, or in locations with lower internet bandwidth. The second project I will talk about aims to fill this gap by exploring how the combination of traditional media, such as voice conferencing and instant messaging, and the visualization of shared gaze influences collaboration performance. We conducted a within-subjects experiment where 24 pairs of participants had to collaborate by transmitting critical information to solve 4 different mysteries, a common task in media studies. Each mystery was completed under a different condition: voice, where the communication was achieved via voice conferencing; voice plus gaze, where we added a visualization of a shared gaze; text, where collaborators communicated via instant messaging; and finally text plus gaze, which again added the visualization of shared gaze. For each task, participants were provided with an image of the crime scene, a police report, and profiles for each of the 3 suspects, and had to solve the mystery within 10 minutes. Some of the clues were shared, while others were unique for each participant and critical to the successful identification of the suspect. During text-based communication, shared gaze had a positive effect on task correctness. Similar improvements observed during the voice-based communication agree with prior studies. However, the completion time was improved only for audio-based communication. This finding indicates that shared gaze induced qualitative changes in the text-based collaboration process rather than simply facilitating it. Gaze sharing also led pairs to look and talk more often about the shared content on their screens, regardless of the primary signal of communication. When looking at the exchanges between participants during the text plus gaze condition, we find that joint attention and referral to shared visual elements are indeed increased, as exemplified by this exchange of messages. We also looked at the way the participants perceived their collaboration through a series of questionnaires and interview questions. Measures such as perceived joint attention, flow of communication, and awareness of their partner's activity slightly increased during text plus gaze. However, the perceived cognitive workload was exacerbated during text-based collaboration. This was also reflected in our post-study interviews, with participants overall preferring shared gaze when coupled with voice-based communication. Overall, this work highlighted the importance of the medium of communication while building novel applications to support remote collaborations. My group is now investigating what happens when we go beyond the dyad. Recently, there has been work on groups with 3 people, but it is unclear how shared gaze could affect larger teams. Prior work, including ours, has also assumed that collaborators work closely together on a task, but this is not always the case. For example, collaborators might want to optimize resources by parallelizing tasks, or they want some privacy when thinking about the work that they're doing, or they might have different roles, with one person taking the lead and others having secondary roles. It appears that the effect of shared gaze is dependent on the task at hand, and we need a systematic investigation of the problem. So with that, I'd like to thank all my collaborators on these 2 projects and of course you for your attention. I'd be happy to take any questions and hear your suggestions about eye tracking and how it can help us better understand and support remote collaborations. Thank you.